Nanobiotechnology is a space. It's a space that we can design with.
It's intersection, almost the nexus of the sciences. It's where biologists, nanotechnologists, and scientists of all different types come together to study the science of the very small.
The living cell is actually a nanofactory. It makes all of these different components and puts it all together to make a living system. So bio-nanotechnology is using the technology of life and DNA, which is the programming language for living cells, to reprogram the nanostructures to do useful things.
Be able to build smart devices, so therapeutics that can specifically target those cells and reprogram them, for example. And the way that we want to do that is build out of the same thing that nature builds out of.
It's sort of trying to find the overlaps and look at how biological systems are built, and then how can we engineer the biological systems using the built-in tools to build other structures that they wouldn't necessarily build on their own.
So we can have multiple people or multiple teams from different countries try to work together to create a better form than the one nature gives us.
Biology does almost everything in an atomically precise way, and we can now design things using all those tools that have been evolved over the entire era of biology, going back to the dawn of life.
Exploring the question of how do you design nature and how do you design nature well. So trying to bring ideas of critique into the lab and try and explore new kinds of questions that other sorts of research don't touch.
What if to use these tools and to discover them and make them acceptable to the public, we have to give up the notion of the blockbuster drug, for instance. You know, maybe there is another architecture for discovery, another commercial architecture, as well as another public architecture.
When we're talking about designing new genes for bacteria to produce new biomaterials, we have some knowledge, but it's incomplete knowledge. And so that, I think, it's a challenge for designing in our old ways, but it's an opportunity for designing in new ways, for designing in the context of uncertainty.
I think one of the challenges is communicating with the public, because especially for the personal genomics part of what we do, that's not something where we can just be scientists off in our own little corner. We have to actually ask individuals who are the experts about themselves.
You know, it was only 10 years ago that DNA sequencing instruments were only accessible to major institutions like MIT and Stanford or major biotechnology companies, but now they're becoming miniaturized, low-cost, pocket-sized, portable. And what happens when you put these machines in the hands of thousands of people around the world?
It's like a social network expanding globally, and it's just becoming fun. And I see things that are delightful and surprising and really just inspiring everywhere I go. And I love that.
In a way, there's absolutely no reason why we can't all be scientists. We're all expert about ourselves, about what we want. It's time to have a conversation that involves everybody on the planet.